My dear students, welcome to a new science session. Today we are going to learn lesson 2, wave motion. By the end of this video, you will be able to recognize the role of the wave in transferring energy, recognize the concept of wave motion, use the materials and tools to compare between transverse and longitudinal waves, and finally compare between electromagnetic and mechanical waves. Now ask yourself, what happens if you throw a stone in water or when a drop of water falls on a surface of still water? Well, I will tell you the answer. A disturbance will be occurred. This disturbance will transfer from a drop to another on the water surface, which appears in the form of concentric cycles. These concentric cycles are known as water waves, and we will discover more in the following slides. Now, let's talk about the role of waves in transferring energy. Imagine that you are in a sporting event. The fans go up and down during celebrating, but no one has had to move seats. So, waves can transfer energy from one place to another without transferring any matter. This is done by a series of disturbances or vibrations which carry the energy. Waves can transfer energy through solids, liquids, gases, and empty spaces or vacuums. From the previous example, we can conclude that wave motion, it's a periodic motion produced as a result of the vibration of the medium particles at a certain moment and in a definite direction. The line of wave propagation is the direction through which the wave propagates. Now let's talk about types of waves. We have 2 points of view. We can classify waves according to the direction of vibration of medium particles relative to the direction of propagation into transverse waves and longitudinal waves, or we can classify waves according to the ability to propagate and transfer energy into electromagnetic waves and mechanical waves. How does sound energy travel? Wonder how that works? Come to Dr. Zoc. We are going to learn how sound energy travels. And there are mainly 2 types of waves, which are transverse waves and longitudinal waves. Let's see how waves travel. We use a slinky spring to discover the 2 types of waves. Emily is holding one side of the slinky, while Dr. Zoc is holding the other end. By moving the end of Dr. Zoc up and down, he is sending energy travels through the slinky. Notice how the slinky moves. This is a transverse wave, where the medium particles vibrate in a direction perpendicular to the direction of wave propagation. Now, let's see how the longitudinal waves look like. You can see that Dr. Zoc is pushing the slinky towards himself and pushing it towards Emily. So, you can conclude that in the longitudinal waves, medium particles vibrate along the direction of wave propagation. And of course, sound waves are longitudinal waves. If you compare between the longitudinal wave and the transverse wave, you will find that in the longitudinal wave, there are compressions and rarefactions. Compression, it's the area in the longitudinal wave at which the particles of the medium are of the highest density and pressure, while the rarefaction is the area of the longitudinal wave at which the medium particles are of the lowest density and pressure. On the other hand, in the transverse wave, there are crests and troughs. Crest, it's the highest point of the particles of the medium in the transverse wave, while the trough is the lowest point of the particles of the medium in the transverse wave. In the wave motion curve, the crest of the transverse wave is equivalent to the center of compression of the longitudinal wave. On the other hand, the trough of the transverse wave is equivalent to the center of rarefaction of the longitudinal wave. Now, let's relate science to our daily lives. Jacuzzi. Jacuzzi is found in most health clubs, where water moves in the form of circular waves. Jacuzzi is used to treat sprains and cramps by using hot water, or it's used to treat nervous tension by using cold water. My dear students, thank you so much for good listening and see you next time in the last part of this amazing lesson. This video is created by Mr. Mohamed Hamdy, science teacher at Mansoura Royal Schools. See you next time.